Determine if each graph represents the graph of a function. Well, we can do that with the vertical line test. So let's see. This definitely fails. This one passes. This one passes even at this point because the other point's not allowed. And this one passes. So this is our only failure. And then, let's see. If so, determine whether the graph is the function of a one-to-one function. Okay, so one-to-one is the horizontal line test. And this one, well, we don't care. We don't care about the first one. We just say it failed the first one, so we're good. And then over here, it may look like it's flattening out, but never quite. So it passes. And this one definitely fails because it's down the line. And that's not okay, so it fails the horizontal line test. And same thing with this one, fails the horizontal line test. Find the domain of the function defined by each question. Well, let's see. What are we worried about with a? We're worried about a plus 2x. We want to make sure that that is greater than 0. It's okay if it's 0. So we can solve for x there. And let's see, for b, we'd say, well, x squared plus 1 can never be 0. But don't worry, I can't make x squared negative, so that's never going to happen. But I am concerned about x as far as the top goes. It's okay if it's 0, but it cannot be less than 0. So it has to be greater than or equal to 0. And like I said, the bottom doesn't really cause us any trouble. So we would say, let's see, where are our trouble spots for C? And the trouble spots are 2x plus 1 is not allowed to be equal to 0. And also x minus 3 is not allowed to be equal to 0. So we can solve for what x is not allowed to be. And I think I'll do the one in the middle. I will just say the domain is equal to, or the domain is, we'll just say, let's see, it's greater than 0, so, oh, but it's equal to 0. It can be equal to 0, so hang on. Use a bracket, 0, and then it can be as big as it wants. Okay, so there's the domain for the second one, for B, and you can tell me the domain for A and C.